morning, welcome to the lab of macro and quantum optics. In this lab, we have 3 big rooms shared by 10 academic staffs. Our research focuses on the light-matter interaction in macro and nanoscale and the quantum effects of light. We start with the first optical table, which belongs to my group. And this optical table is an optical macro spectroscopy setup. What does this mean? It means that by using this experimental setup, we can measure the optical properties of materials and devices by measuring its emitted light, reflected light, and transmitted light. So this setup really allows us to do this characterization in macro or even nanoscale. Now, please let me explain how it works. So the whole setup can be divided into 3 regions: the light source region, the microscope region, and analysis region. So in the light source region, we have different types of lasers and white light sources. So we put in the optical path a couple of flip mirrors that we can flip in and flip out to allow different lasers come to the next region. So in the microscope region, we send the excitation laser from the light source region to the sample. So how do we do that? So we use an objective lens to focus the excitation beam to the sample to excite it. So the sample can reflect the light, or it can absorb the light and emit light of its own. Then the emitted light from the sample can be collected by the same optical path and then sent to the 3rd region for analysis. Okay, so the microscope setup really allowed us to select where we want to excite the sample and where we want to collect light from the sample. Okay, so when the light is sent to the analysis region, we use a spectrometer and a CCD camera to characterize it. So before the spectrometer, we built an optical path of an imaging system which allowed us to image the light emitted from the sample to the entrance of the spectrometer. And then the light is sent into the spectrometer and analyzed and detected by the CCD camera, and its spectra and spatial information, we can read it from the computer. Okay, so by engineering the optical path here, we can study different properties of the samples, including intensity, phase, angular distribution, and polarization. So, by using macrospectroscopy, we characterize the new generation of light-emitting materials, macro lasers, nanostructures, and explore the fundamental physics of how light and matter interact at macro and nanoscale. Thanks.